Okay, welcome back to the Dublin Academy of Maths online. Now, Michael is my name and it's Leaving Cert Early Level Maths Series 5 Episode 7 and it's Paper 1 and we're dealing with sequences of series, and today we're dealing with a geometric sequence. Now, so now we've dealt with arithmetic sequences. We're now dealing with geometric sequences where each term has a common factor. Now, the other time we were dealing with arithmetic sequences of plus or minuses. You had a plus something or a minus something. But this time we're dealing with multiplications. Okay, so get to know the difference, right? What's the difference between an arithmetic and a geometric? Okay, so they have a common factor, right? Now, the common factor is known as R. Okay. Now, in T of N, it was known as D. Okay, do you remember the difference? Okay, so put this. To stop you from confusing, put in R. So to find R, it's called a common ratio. Okay, you divide any term by the previous term. Okay, to find it, so you divide any term by the previous term. So 16 over 8 or 4 over 2. Okay, 16 over 8 is equal to 2. 4 over 2 is equal to 2. Okay, so there you can see it. Okay, now I've kind of explained it here. So this is A, the first term. Okay, so we have to know the first term. A is the first term. R is the common ratio, what we multiplied it by. Okay, and it can be division. Okay, so remember, Tn is plus or minus, and GS are geometric sequence is equal to multiplication or division. Okay, it's known as Gn. But So we come up with this solution. So they've noticed a pattern here, okay? And they looked at this pattern and they came. So T1 was equal to A. T2 was equal to AR. So it was going along like T3 was equal to AR squared. So it was AR by R, AR cubed. So they decided that they derived the formula that Tn is equal to A, or Tn is equal to AR times n minus 1. Okay? So that's the way they've put this formula, okay? In Tn, not in the Gm. That's the Gm is the next. The GS of something is next, where you sum it all up. So remember that Tn is addition or subtraction, but we're referring here to the AS. Okay, so then let's not cut this. This is for the GS. Okay, geometric series, right? So it's expressed as Tn. Right, so remember that. So they came along with this formula, and that's how it is. So what you have to do is you have to work on the formula, okay? So a question would be like, so that last question, so 2, 4, 8, 16, we know that the common factor or is equal to, which is equal to, multiplied by 2, okay? So we found out that it was equal to 2. Do you remember from the formula? One over the other. Now I'm going to draw this out here. This is not going to make any sense at the moment, but remember this. I'm going to show you how to do this to find other terms. Okay, I'll explain in much more detail, but it's basically just similar to triangles. It's similar to ratios, but we will do 1 over the other is equal to this side as well. You did that before in geometry. In junior cert, I imagine you did it there, but we will go over it. So in a geometric sequence, or GS I'm going to call it now, T2 is equal to a quarter, okay, and T5 is equal to 2. Now, so I'm going to try and it says find A, the first term, and R, and then express as Tn. Okay, so that would be it, right? Now, so I've got two. Right now, these are ratios. Now, you might have remembered ratios. Ratios was to do with a triangle, but I'm going to put it into a triangle type thing. So, in order for me to discover what the first term is, I need to start playing around with this. Okay, so T1 was equal to A. Okay, so T2 is equal to A times R. Okay, which we have, which is a quarter. Okay, so remember this. So T T3 is equal to AR squared, T4 is equal to AR cubed, and T5 is equal to AR to the power of 4. So you can see that it's multiplying by its R all the way along, by its constant ratio. Okay? So the constant ratio is R. And ratios, as I said before, was brought into geometry of triangles. It was in higher level geometry. So now I'm looking at T2, I've got T2 there, and I'm looking at T5. Okay, so this is what I'm looking at. So T2 is equal to a quarter, okay, and T5 is equal to 2, alright, and both, this is AR and this is AR to the power of 4. Okay, so that's my information now I've got so far. Alright, so what I'm doing is I'm writing everything down and I'm trying to discover what to do with it, okay, trying to find a result for it. Okay, so I've got these two. Now the next part is that I must represent these ratios as a fraction, okay? So if T2 is equal to a quarter, which is AR, okay? So I can write this down as a fraction. I can write it down as T5 divided by T2, okay? Which is the same as AR to the power of 4 over T2 is AR, okay? So A goes into A once, it's not A to the power of 4, okay, so that's A is gone, and the R goes into so it's R to the power of 3, and that's indice rules. You bring it up and you subtract the indice. But you can imagine R's, 4 R's and 1 R down there, you cancel and you're left with 3 R's. Now, so this, so if I was to represent T5 over T2, I would get, I would put them into fractions. Okay, so let's look at this as a fraction. All right, so we have our fractions here. So it's T5. It's 2 over a quarter. Okay, it's 2 over a quarter. Right, and from there we find out what R cubed is equal to. Right, so that's so in other words, R cubed is equal to 2. This implies that R cubed is equal to 2 over a quarter, which the values we were given earlier on. Okay, so now we can start multiplying it out. So R cubed is equal to 2 divided by a quarter. Okay, so you turn it upside down, it becomes 8. It becomes 4 over 1. Do you see? Multiplied, and it becomes 8. So R cubed is equal to 8. Right, so that means R is equal to, bring the cube root across, and becomes the cube root of A, which is equal to 2. So that's my first answer. R is equal to 2. Right, now we've got this before because we're doing this. We're doing the same question, but we're going to show you how to get them. Okay. So I'm giving these values. We're given these values. Okay, but we don't actually know this, right? Because they're not telling you. But it seems to be a very common expression because there's not a lot of big numbers to be messing with. So anyway, so R is equal to 2. Right, so we've got that. So if R is equal to 2, and I know that T2 is equal to AR, and AR is equal to 2, okay? So you see what I'm trying to do. Sorry, AR is equal to a quarter, right? Because T2 was a quarter, okay? So so I know that what R is equal to. Okay, so R is equal to 2. So I'm putting back in my values, right? So you see that it's 8 times 2 is equal to a quarter. Okay? And I bring it across the 2 and it becomes multiplication, becomes division. Okay? So it becomes A is equal to a quarter divided by 2, which is equal to a quarter divided by 2 over 1, which is equal to a quarter multiplied by 1 over 2, which is equal to an 8. Okay? I just check that answer. A is equal to an 8. That's what A is equal to. Right? So let's get back to this thing here, what I was doing earlier before, right? So if I start if I get in the habit of drawing a triangle, I will know that if I have T3 and T2 and T3, and these triangles keep going along, and this is T3, T4, and this is T5. Okay? And I know that that divided by that is the same as T5 divided by T2, which I have. Okay? So you see what I'm getting here at? It's kind of like remembering that you can actually do this, and it's the same with the finding the mean A, B, C. Do you remember we were finding the mean and we said that A plus C is equal to 2 times B? Well, it's something similar to this. This is all related. Maths is all related, even to geometry. Okay, so we have A is an 8. So now we've discovered, and now we can write in our term. And our term is Tn is equal to A times R to the power of n minus 1. You have to learn this, okay? So we know that A is an 8, R is 2, and we don't know n, okay? We can find n, but anyway, we're just simplifying this formula so as we have a nice formula for this array of numbers, okay? So that's 2 to the power of n. 1 over 8 is the same as 2 to the power of 3 times 2 to the power of n minus 1. I can bring that up and it becomes 2 to the power of n minus 1 minus 3. Okay, do you see that now? I'll do that again. That's 2 over to the power of 3. I brought the 2 up and it's an indice rule. Indice rule. I've got x to the power of m over x to the power of n. Bring it up is equal to x to the power of m minus n. Okay, I hope you can see that. So this is going to be equal to 2 to the power of n minus 1 times 2 to the power of minus 3. Cancel the 2 with that, we don't need the same base. This is equal to 2 to the power of n minus 4. Okay, that's the way we get, so we can express that as that. Okay, let me just check that answer. Where am I? Right, 2 to the power of, okay, that's correct. Now, if the next thing it says, so you've expressed it now. That's your expression. So Tn is equal to 2n, 2 to the power of n minus 4. So now you have expressed that array of numbers and you can find your T1, T2 and T3 by putting it into the formula. T is equal to 2 to the power of n minus 4. So you put in your first number, so it's going to be 2 to the power of 1 minus 4, which is equal to 2 to the power of minus 3, which is equal to 1 over 8. Okay, put in 2 for your value, in for n, so we got 2 minus 4 is equal to 2 to the power of minus 2, which is equal to 1 over 2 to the power of 2, which is equal to 2 to the power of 2 is 4. Okay, and 3, we put in 3 again for n. Remember that we're using this formula here, because we got the formula, we derived the formula. T of 3 is equal to the same, you put it in for n, 3 minus 4 is equal to 2 to the power of minus 1, which is equal to 1 over 2. Okay, 2 to the power of 1. You see that? Okay. So it's actually going up. Right? Anyway, where are we now with this? Right, okay. If Tn is equal to, I just want to have a look at this one. That seems to be everything now. You've found a lot of things here and you've done a lot of work, okay? I don't think I want to give you any more work here. I'm looking and I'm saying, now that's the whole question answered. I'm just looking at this. If Tn is equal to 2 to the power of 3, 2 times 3 to the power of n plus 1, show it's a geometric sequence. Okay, now if it's a geometric sequence, remember that Tn over T n minus 1, you'll get R. Okay, remember that now. Okay, so that's a good question to do. You put in your values. So right, there's nothing really here. There's nothing really. So remember that T2 over T1 is equal to T3 over T2. Okay, so you remember that you can get your previous values by dividing by you can get your R by dividing your previous value, by dividing that number by the previous number. Okay. Okay, well we leave it at that. So that's everything. Now remember these questions over here. Now this is the start of it, so it's not too difficult. Write down the common ratio R. So you have to look at what's the common ratio. You can figure that out or you can use the formula, okay? Anyway, so there you go. And write down the first three terms of the following. Tn is equal to 2 to the power of n. You put in 1. T of 1, you put in 1 is equal to 2. And you put in 2, you put in 3. And so forth. Okay, so you have to put in your values 1, 2, and 3. The first three terms. T of n is equal to 4 times 2 to the power of n minus 1 of a geometric series, G of s. Find a, r, and t of 20. Okay, well, a is the first term, r is the difference, so you have to go along. Okay, now in this GS, T2 is equal to a half geometric series, T2 is equal to half, and T5 is equal to 4. Okay, not like the last one. Okay, so no, similar to the last one. Find a, r, and t of n, the expression t of n. So remember, you'll have to go and do your division here and get the common r. Right? So that's everything now. Just want to say, make sure you do the questions. Questions eliminate all errors. That's great. Take care now.